Unsolved mysteries of the strange universe. Dark matter, the spider's web. Planets, stars, asteroids, galaxies, the things we can see represent less than 5% of the total universe. Scientists think that another 25% is a foreign substance called dark matter. We can't see it, we don't understand it, but we are sure it is out there, because everything is moving in its gravitational tone. Scientists believe that dark matter acts like a spider's web, joining fast-moving galaxies. And there's so much of this stuff that actually bends the appearance of space, so that when astronomers observe distant galaxies, they often appear distorted. We have a lot of evidence that dark matter exists, but as to what it is, it remains a mystery. Some think that dark matter is composed of an undiscovered particle or particles, others believe that it is a property of undiscovered gravity. Whatever the truth, dark matter is a real enigma, and it has been extremely difficult to determine. Dark energy, the poltergeist. If dark matter makes up 25% of the universe and normal matter makes up 5%, what makes up the other 70%? Scientists think that the remainder is entirely dark energy, powerful enough to tear the entire universe asunder. It is believed that dark matter appears to mesh galaxies together. Dark energy seems to want to push everything apart. We all know that the universe is expanding, but it's expanding more and more quickly than it should be, and scientists think that dark energy is the culprit. But where's dark energy coming from? Some believe that it's produced from collisions between quantum particles, but no one knows for sure. Quantum entanglement, spooky action. Famously dubbed spooky action at a distance by a dubious Albert Einstein, quantum entanglement is the phenomenon by which two particles in totally different parts of the universe can be linked to one another, mirroring the behavior and state of their partner. Physics quantum entanglement is a bit of a nuisance, because it breaks some fundamental laws that were previously thought to be unbreakable. For example, particles to be connected across such vast distances, they must be sending signals to one another that travel faster than the speed of light, a feat previously considered impossible. What's more, objects are only supposed to be affected by their surroundings. The notion of a particle being affected by something happening on the other side of the universe is just strange. Nonetheless, studies suggest that quantum entanglement does indeed exist. Despite the fact that we do not understand it, we could still potentially use it. Its weird characteristics, entanglement could eventually become the bedrock of next-generation computing and communications. So, watch this space. Antimatter, the evil twins. Imagine yourself in opposite land. Black is white, up is down and matter is antimatter. It sounds crazy, but the subatomic particles that make up everything around us, electrons, protons and neutrons, all have evil twins. We believe that antimatter particles are the same mass as normal particles, but with the opposite electric charge. And because of this, antimatter wipes out normal matter on contact. Poof. Both are destroyed in an instant. So, antimatter has the potential to destroy us and everything we love. But fear not. There's very little antimatter roaming around in the cosmos. What's more, antimatter could even prove useful. When antimatter and matter meet and destroy one another, it releases energy. Test in a PET scanner, anti-electrons are created and their annihilation in the body allows doctors to create sophisticated images. What's more, scientists hope to one day use the energy released by antimatter-matter interactions to power spacecraft. So perhaps antimatter isn't quite so evil after all. The Fermi paradox, little green men. The universe is really big, like, really big. In this massive universe, human beings are simply small fry. Despite this fact, we currently seem to be the only ones in the game. The contradiction between the high probability of extraterrestrial life and the apparent lack of evidence that such life exists is known as the Fermi paradox. We've now identified a handful of potentially habitable Earth-like planets, but we're still yet to see any signs of intelligent life from out there. So why the radio silence? Several theories, ranging from the possibility that intelligent life is exceptionally rare or short-lived, to the notion that alien species are purposefully avoiding detection.